continuing to graph these really fun things. Today we've got lemniscates and rose curves, okay? These are what you see right here is what you're going to be given on your formulas that you're going to be given, okay? So please take out your formula sheet and make sure you're using it as we look at this. A lemniscate is a figure 8, okay? I like to say that in my head, lemniscate, figure 8. Lemniscate, figure 8, all right? It's pretty cool. Hey, you know it's a lemniscate when something is squared, when r is squared, okay? Cosine lemniscate starts at 0, okay, along the horizontal axis, and then a sine is along pi over 4, okay? You're going to know A, and A is going to just be your length of your lemniscate, okay? Rose curves, we're going to get into that a little bit more. We'll talk about that after we do lemniscates, figure 8s. Lemniscates, 2 loops with a length of A, okay? You know it's a lemniscate because it's r squared. Beep. All right, here we go. Let's graph it. So we've got sketch the graph of each polar coordinate. We've got r squared is equal to 4 cosine 2 theta. Okay? So cosine, right, tells us we're going to start at 0. I don't know why my pen's looking like this. All right, so we're going to start at 0, and then 4 is equal to r squared, so r is equal to 2. Okay, so you're going to go out here, you're going to go 2, put a dot, obviously going through the middle. You're going to go to the back and put 2. And then in your head, you say lemniscate, figure 8. Boom, boom, you're done. Number 2, okay? Wait, let me make sure that's a cosine, yeah. Okay, number 2 also says cosine, okay? So we're going to start at 0. And 9. Oh, earlier I said r squared. I didn't mean to. I meant to say a squared. So a is equal to 2. All right. Anyways, back here. A squared is equal to 9, so a is equal to 3. So I'm going to start at your center. I'm going to go out 3 tick marks. I'm going to go back 3 tick marks. Lemniscate, figure 8, and then you're done. You know that those are the same because it's r squared. So you're like, well, you didn't even give us one that said cosine. I actually think on your paper it does say cosine. The second one. I don't know why ours doesn't. I think yours says 9 sine 2 theta. Hopefully it does. Okay? Which means you're not going to start at 0. You're going to start at pi over 4. Okay? So pi over 4, you've got to look at this, and it's got to be this guy in the middle. So we've got a squared is equal to 9. We've got a is equal to 3. So we're going to go out 3. We're in the middle, and then we're going to go down 3. Lemniscate, figure 8. Pi over 4. Don't start at pi over 3, pi over 6, any of those. All right, now we've got our fun rose curves. Okay, you've got to look at this. You've got to look at n. When n is odd, we have n petals. When n is even, we have twice that. Each petal is spaced the same distance apart from the petal length of A. So r, if it's cosine, we're going to start at 0. If it's sine, we're going to start at pi over 2 divided by 2n. Again, you need this paper out every single time we're going to do rose curves. Okay? Our distance apart, okay, we can do it several different ways. I'm going to try and do it like 2 different ways. Okay? So, let's get going on this so you can see what in the world we're supposed to be doing. Okay, so we have r is equal to 5 cosine 4 theta. So it's no longer r squared, so it's not a lemniscate. Okay? It's not a lemnis because nothing is being added or subtracted. And it's not a circle because there's a number in front of your theta. Okay, so let's look here. We're saying, okay, n. So we've got a, and then we have n. N is even. When n is even, that means we have 2 times 4, so we're going to have 8 petals. All right, we've got 8 petals. Okay, then the next thing it says, each petal is spaced 2 pi over a number of petals. So it's pi over 4 apart. Okay, and so here's what some people are thinking. You're like, how am I supposed to pi over 4 apart? All right, so as you look at this top thing, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have 12 apart on top, okay? So actually, we're going to go 3 pi over 12 apart. Does that make sense? So now once you have your first one, then you're going to count 3 tick marks and do it again. Okay? Or you could say, hey, yeah, no, let's do that one. Okay? So it's pi over 4 apart, which is the same thing as 3 pi over 12 apart. All right? And then it's cosine, so we're going to start at 0. And my a is 5. So I'm going to go 5 out. All right. So I've got this guy in the middle, and so we're going to go 5 out. 1, 2, 3, 4, 5 out. Perfect. Okay? And then you're like, all right, I got to do more. And so we're going to go 3 away. 1, 2, 3, put a dot. 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 Okay, so we should have 8 dots on there because that's going to tell me, hey, I've got 8 petals. Let's make sure. 1, 2, 3, 4, 5, 6, 7, 8. We do have 8 petals. All right, and now you're going to get to draw these petals. Sometimes I think it's fun to try and figure out how to draw this without picking up your pencil and without retracing something. Woo, flower. Okay, it's a rose. It's a rose petal. Okay, rose curve. Pretty fun. That's what it looks like. You've got to practice for it to make any sort of sense. Okay, here we go with number 4. We've got 2 sine 3 theta. So my A is 2, my N is 3, so N is odd. So that means I have 3 petals. Okay, 3 petals, right? And they're going to be spaced 2 pi over 3 apart. And you're like, ooh, I don't know what that is. Okay, let's make this 12. So they're going to be spaced 8 pi over 12 apart. Okay, and then where do I start? Okay, it says with its sign, you're going to start at pi over 2 times n, which is 3. Okay, you're going to start at pi over 6, and you're like, what? I don't even know where that is. Okay, let's make sure that we know where pi over 6 is. If we turn this into terms of 12, because on top there are 12 of them, we're going to start at the 2 pi over 12. All right, and now a is equal to 2, so it's going to be a length of 2, which is going to be a little bit smaller of a guy. Okay, so we're going to start at 2, so that's 1, this is 2. Okay, so I'm going to go here. This is, ooh, I don't want that color. My starting point is here. 1 second. All right, here we go. So that's where 2 is. All right, so now I'm going to go out 2. And now I've got to count 8 pi apart. So 1, 2, 3, 4, 5, 6, 7, 8. Put a dot. 1, 2, 3, 4, 5, 6, 7, 8. Put a dot. All right, and then here we go. 3 petal rose curve. Look here. All right, it's cosine. This is A, this is N. So N again is odd. So I have 3 petals. We just did one like this, but let's go through it again. It's 2 pi over 3 apart, which is going to be 8 pi over 12 apart. I'm going to start at 0 because it's cosine. Cosine starts at 0. And then my A is 4. All right, so I'm going to go out. 1, 2, 3, 4. Put a dot. Now I'm going to count 8 apart, right? It's the same-ish as last time, but it's not going to look identical because we're starting at different spots. So I'm going to count 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Perfect. All right. Great. Let's do a sine guy. It's sine, that's A, that's N. So N is even. So it's 2 times 2, so I have 4 petals. Let's see how we space them apart. 2 pi divided by the number of petals, so 4. They're going to be spaced pi over 2 apart. which is actually 6 pi over 12 apart. Okay, it's sine, so it says sine starts at pi over 2 times 4. So this is pi, oh, no, not pedal, sorry. I'm like, that doesn't make sense because there's no pi over 8. So it says pi times 2n, and n is 2. So we're going to start at pi over 4, which is 3 pi over 12. This is where we start. And then a is equal to 4. Okay, so I go 3, 1, ooh, no, I want this. 1, 2, no. 1, 2, 3. Okay, that's where I start. I'm going to go out 4, so 1, 2, 3, 4. All right, and then I'm going to count 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Perfect. Ooh, yikes, that guy didn't look good. But here we go. Okay, I think making this in terms of 12 on the denominator is going to make or break it. Okay, totally make or break it. Okay, last few things to identify polar graphs. Okay, a circle, we've got no positive, negative, and no number in front of theta. Cardioids is going to be the same number. Lemniscate is lemniscate with inner loop. The first is smaller. Dimpled, first is bigger. Lemniscate, figure 8, is r squared, and then rose curve is there's a number in front of theta. Okay, so to identify this, right, the easiest ones I think right now are this r squared. Okay, r squared and r squared, we're going to go lemniscate. Okay, the next one I think is easiest is for a circle. A circle has nothing in front of theta. Okay, so this guy has nothing in front, and there's also no positive, negative. Those have positive, negative, those have positive. This guy has nothing in front, and that's all. So these are circles. Okay. So then the rose curves are the next best because nothing is added or subtracted. Okay. Rows and rows. All right, now 8, 9, and 10, those are going to be lemniscates. Okay. Lemniscates, so for a cardioid, A is equal to B. So 1 is equal to that guy, which is 1. Here's a cardioid. Okay. For inner loop, okay, A is less than B, right? A is less than B. So which number is smaller? -1 is smaller than 3, so this is inner. And then a dimpled means it's kind of like going outer, and that is going to be when A divided by B, so like 6 divided by 5, is that between 1 and 2? Yep. Here we go with dimpled. Okay, you've got to practice this. You've got to look at it. You've got to ask yourself, hey, what am I doing? What am I looking at? Which are the easier ones to do? All right, let's get more practice with the homework.